Okay? So to start, we've covered all of our different methods of factoring for solving quadratics. The first one being factor. Okay? They all have their advantages and disadvantages. Factoring is usually the fastest and the easiest. Problem is, not everything can be factored. So it's not as reliable when we get to some more complex problems, especially when we're dealing with applications, because the world isn't a nice, neat, easy place. So factoring isn't always available, but if you can, generally going to be the fastest, less room for error. Square root property. If we are given a quadratic in standard form, then square root property is going to be the easiest one. Don't bother expanding it. I see it all the time. When you have a quadratic that is, say, written like this, and then I see you guys expand it, and maybe you have it here, and you expand it into 9x squared plus 12x plus 4 equals 7, and then you move the 7, get it in standard form, and try and solve it from there. You're doing way too much work. Square root property is there for this situation. When you have a quadratic in vertex form, square root both sides, solve from there, plus or minus. Problem is, most equations aren't given in that form. It's rare that they show up like that. Now that's where completing the square comes in handy. If we want to use the square root property, we can use completing the square, and we can always do that. We can always complete the square with any quadratic and get it into vertex form. The thing with that is that it's a little bit more time consuming than quadratic formula. Most people prefer the quadratic formula. The benefit of completing the square is going to come a little bit later when we need more than just the value of x. I need to know what my x-intercepts are. I need to know what my y-intercepts are. I need to know what the vertex of my quadratic is. That's where completing the square comes in handy, because I get all that information from one form of the equation really easily. And then quadratic formula is kind of our catch-all. Always works. Most of the time you'll be using those two. They're the most common, most comfortable, but there are uses for the others depending on what we have. So it's important to make sure that you're aware of all of those. So with word problems, there's a couple things you're going to want to do. One, make sure you read it carefully. You may need to read it multiple times. Okay? Secondly, if there's not a diagram provided, usually it helps to have a diagram. So you may need to draw one on your own. I don't expect you to be artists, but draw a picture so that you can make sure that you truly understand the whole process that's going on. Okay? So a ladder is leaning against a house. Oh, look, I have a house. Beautiful, right? A ladder leaning against it. Make it a little bit bigger. Got a ladder leaning against it. The distance from the bottom of the ladder to the house is 5 feet. The distance from the top of the ladder to the ground is 1 foot less than the length. How long is the ladder? This is what we want to find. So, if I don't know what something is, what do I use to represent it? Variable. So we could use x, we could use L, we could use whatever, it doesn't matter. Okay? So we have a variable. So I'm trying to solve for the length of the ladder. That's going to be x. So now I have to deal with this height here. It's 1 foot less than the length of the ladder. So what can I use to represent the distance from the top of the ladder to the ground? X minus 1. So now, I've got all my information written out. Okay, they gave me 5 feet, the distance from the bottom to the house. X minus 1 represents the top to the ground, and then X represents the length. Given 3 sides of a triangle, what do I use to find any missing information? Yeah, our Pythagorean theorem. So whenever we have triangles, we are using our Pythagorean theorem. A and B are the legs. C is our hypotenuse. which one's A and which one's B doesn't matter as much, but the value of C is important. So once you can properly identify C, then you can't screw up the rest of the formula. So how can I tell, given any triangle, which side is my hypotenuse?
Oh, it's directly from...
Exactly. Because looking at this diagram or sketch, there's no way we can tell which side is the longest, but I know that the longest side will always be opposite the right angle. Okay? So house forms a right angle with the ground, as long as your contractor is actually good. And directly opposite will be that hypotenuse. So now we can just plug in. Which side is A and which side is B doesn't matter. Okay? We can make this A and this B. What's really important is this has to be C. There's no other option. Okay? So we just plug it in. A is x minus 1, quantity squared. B is 5 squared. And C is x squared. Let's expand it. What's x minus 1 squared? X minus 1 squared. Uh-huh. Uh-huh. Good. Plus 25 for squaring the 5, and we've got x squared. Okay, so now I need to continue to solve. What's going to be next? Say again? Combine like terms. I've got the 1 and 25 to get 26. Come on, eraser. Thank you. There we go. When I group everything to one side using my inverse operations, I subtract this x squared to move it over. Yeah, that's going to cancel. Keep going. Subtract 26 and divide by -2. So I get the ladder is 13 feet long. Not so bad. All right. There's a lot of information here. Don't let it overwhelm you. We just need to parse through it piece by piece. Look at what we have, and then reason through what we need. Reason. That's the key with pretty much every application. It's more about, it's not just about solving equations, because we can do that. It's reasoning, problem solving, and critical thinking. Okay? So that's really what we're testing at. We're just given a toolbox of equations and ways to solve to approach these. There's a typo on the diagram, and we see it in the word problem. It should be 40 feet long, not 30 feet long. Okay? So we have a pool, 20 feet by 40 feet. The homeowner wants to plant a strip of grass around the edge of the pool. There is enough seed to cover 700 square feet. How wide should the grass strip be? Okay? So we're given dimensions of a pool, length and width. We're also given dimensions of the entire section, okay? The pool and the grass surrounding it. I want you to understand where those expressions are coming from, because it's just going to be basic addition. But if you don't see it right away, the 40 plus 2x, note that x is, hey, this is how wide our grass is going to be. I don't know how wide it is yet, but he wants an even strip all the way around. Okay? So the distance from any edge of the pool should be the same distance for the grass. So to get that entire length, we're taking the 40 feet that we have for the pool, and adding x feet onto either side. So that's where we get our 40 plus 2x. The 40 of the pool, x on one side, and another x on the other side. And the same goes for the width. 20 feet for the width, plus the x on one side and the x on the other, to get that entire distance from one side of the grass, to the other side of the grass. All right, so that's where all those values are coming from. So if I'm dealing with area, and I have rectangles, what formula am I going to use? Times width, area of a rectangle. Okay, so we need to focus on this as the foundation for our problem. There's another thing I want to ask you about. So given the length and width of the pool in integers, I can find the area of the pool. So I know, essentially, the area of the pool. Given expressions that represent the full length and the full width, I can find the total area as well, or at least have an expression that represents it. Total area. In the equation, or in the problem, I'm also given the area of the grass. Area of the grass. Okay? Or how much I can have as an area. But it's not a rectangle, it's several rectangles around the edge. Or a rectangle with a hole in the middle. So what I want you to think about is, given those pieces of information, if I know how much the area of the pool is, I know how much the total area is, and I know how much of the area of the grass, what would I do to kind of get that total given the area of the pool or the area of the grass, or to find the area of the grass given the pool and the total? Mathematically, what can I do with those three pieces of information to write an equation? Just in really general terms. To what?
Actually, subtract the area of the pool.
Yeah. You could also add the area of the pool to the area of the grass to get the total area. Either way is fine. But just understand the mathematical relationship. If I take the pool away from the total, it gives me just the grass. Or if I add the pool and the grass, it gives me the total. So either way, we're looking at taking the total area. Not working. Give me my eraser. We're taking our total area, and it'll equal the sum of the pool and the grass. So that's kind of our basic foundation of that entire expression, and with the exception of the grass, these are going to be based off of length times width. So let's start with the total area. What expression could I use to represent the total length? The whole thing, total length. What do I have in my diagram that represents the total length? 40 plus 2x. So length of the total area is 40 plus 2x. And what about width of the total area? 20 plus 2x. So I have this algebraic expression that now represents the total area. Now how can I get the area of my pool? What represents the length? 40 times 20. And that'll be added to the area of the grass. How do I get the area of the grass? It's in the problem. What is the area of the grass? 700. So I can add in the area of the grass. And so now I have an equation that just has one variable in it. All I need to do is solve for x. And that'll tell me how wide the grass needs to be. So we expand. 800 plus 80x plus 40x plus 4x squared equals 800 plus 700. So now it's just a matter of combining like terms, writing in standard form, and then picking a method to solve. So in standard form, we're going to have 4x squared plus 120x minus 700 equals 0. We can solve this by factoring.
How'd you get 0?
Combine my like terms to get the 120. I have 800 and 800. When I subtract the 800, it goes away. And then when I subtract 700, now it's 700. And the equation said equals 0. So if I want to factor this, what can I do first?
You can
Factor out the 4. That leaves me with x squared. What?
Plus 100.
And then I can factor. Factor of factors of negative 175 that add to 30.
175 and
175. Not 30.
35.
35, there you go. Yeah. So I've got x minus, I'll have you wrote down there. X minus 5 and x plus 35. Okay, so we factored it pretty quick. Now, last step to solve. Set them to 0. So I've got x minus 5 equals 0, x equals 5. I've got x plus 35 equals 0, x equals negative 35. So how long is the grass, or how wide is the grass going to be? 5 feet. Can't have a negative length. So we can exclude the negative 35. So if you set it equal to 0, it gives you a statement that just doesn't make sense. Alright, so these again, when they give you the equation, honestly, I think those are the easiest. You just need to make sure you're plugging in values to the correct place. Sometimes you're going to solve for the variable, sometimes you're not. Sometimes they give you the variable. It's going to vary from question to question. So make sure you can identify what each thing is properly so that you're plugging your variables into the right place. You're plugging in your values correctly. So I've got a ball projected upwards from the ground. Given this equation, it models its distance in feet at t seconds. Okay? So looking at this formula, what does S of t stand for then? Feet. Distance in feet. Distance measured in feet. What does t stand for? Time measured in seconds. Okay, so make sure you understand what each part represents. The function measures distance in feet. Time is our independent variable to solve. So at what time will the ball be 32 feet from the ground?
So we gotta put 32 equals 8 squared plus 64.
Good.
We gotta put it to the 0, so minus the. And then we can make the. Oh, actually, you take 16 out.
Let's do negative 16.
And then we find the factor that's
So remember, I need product of 2 that adds to negative 4.
oh, -2 and negative.
Doesn't give me a product of 2 though. Doesn't give me a product of 4. Or it doesn't give me a product of 2.
Yeah, negative 2 and negative 2.
I need to multiply to get 2, but add to get negative 4.
You can't do that.
I can't do it. So I can't factor it.
So that's the answer.
What do we do if we can't factor? Quadratic formula. Okay? But shaking out this GCF first makes our quadratic formula a lot easier. I don't have to use this original equation. I can use the partially factored version for the quadratic formula. This is still a quadratic in standard form. I just factored out the GCF. So when I plug in negative b plus or minus square root of b squared minus 4ac over 2a. Alright, all pretty easy numbers to deal with now by factoring out that GCF instead of going straight to quadratic formula. So 4 plus or minus 16 minus 8 over 2. 4 plus or minus root 8 over 2. Alright, and since we're dealing with applications, rarely are we going to have just a radical simplified. We're going to have to round. So what I want you to do is I want you to solve, because remember we have both possible answers, 4 plus root 8 over 2 and 4 minus root 8 over 2. Round to the nearest tenth, please. Round. We'll do both of those. 4 plus square root of 8 over 2, 4 minus square root of 8 over 2. Round to the nearest tenth.
Wait, so what'd you do with the negative 16? You just leave it?
I did. This? Yeah, we just leave it. We factored out. Essentially, I have an equation. I divided both sides by 16. I can get rid of it. I'm looking for what is 4 plus the square root of 8 divided by 2, rounded to the nearest 10. Say 3.4. And I'm also looking for what 4 minus the square root of 8 divided by 2 is, rounded to the nearest 10. What's up, Jordan?
I still don't get why you just leave the negative 16 out.
So what you can do is, so we factored out the negative 16, right? So now I have this quadratic. If I could factor this, I would set these factors equal to 0. I still wouldn't do anything with the negative 16, right? Because it's set all your factors equal to 0. Well, that one doesn't make sense. And then I have this set equal to 0. So this doesn't do me any good. I don't need to worry about it. This I can still solve. I can't factor it, but I can still use it in my quadratic formula. Alright, so when we solved for both solutions and we rounded to nearest tenth, I got 0.6 and I got 3.4. So at what time is the ball 32 feet off the ground? Boom. Are they both reasonable answers? Yeah, they're both positive. That's the only thing for time is it has to be positive, right? So when is it 32 feet off the ground? Well, it starts on the ground and it goes up and it comes back down. So with the exception of when it reaches its highest point, it's going to be at any given height twice. So with the exception of that highest point, it is going to be at any given height 2 times. And so it goes up, it hits 32 feet at 0.6 seconds, reaches its peak, comes back down, then it reaches it again at 3.4 seconds. So it'll reach that height twice. There are 2 answers. Yep, it is both at 0.6 seconds and 3.4 seconds. Now, reading is really important because sometimes they'll say, when will it first reach 32 feet? And then what would my answer be? 0. Okay. And so you got to read the question, make sure you're answering it. If it doesn't specify which of the times, then there's 2 answers. But if it does, it says, when's the first time it's going to reach this, or when's the last time it's going to reach this? Then you have to make sure you're choosing the appropriate response. Alright, so last one in 2 parts. So I've got a formula that represents the number of bankruptcy filings X years since 1990. And it talks about for businesses, okay, when businesses file for bankruptcy. Find the number of bankruptcy filings in 2000. So what does X represent? The year. Well, more specifically, not just the year since 1990. Okay? So the number of years since 1990. So if I wanted to know the number of bankruptcy filings in 1990, what would X be? 0. Because 1990 is 0 years from 1990. What about in the year 1991? And 1995? In the year 2000? 10. So it's the number of years since 1990. So for 2000, we're going to have a value of X that equals 10. All right. What does f of X represent?
10.
Oh. The number of filings in any given year. Okay. So the number of filings in any given year, depending on what X is. So if I want to know the number of filings in 2000, I'm solving for f of X by substituting 10 in for X.
So it's 10.
10 is X. F of X is the number of filings. F of X is the number of filings. So I need to solve f of 10. Oh, I didn't put a 10 in there. Yep.
187.
187.
187.
So in the year 2000, there was 187 filings. For part A, the number of bankruptcy filings in the year 2000, 187. Now part B on the next slide asks for in what years are there 100 filings? What year are there 100 filings? So what am I going to do instead with the 100? F of X becomes 100. Because it's asking when, what year, so we're solving for X, do we have 100 filings? We already established that f of X represents the number of filings. So I would take f of X, replace it with 100, and then write the rest of my equation. Do me a favor, what was my equation?
3.37 times.
Oh, not times 100. The original one.
Oh, X squared.
Uh-huh. Minus 28.6x. Thank you.
Plus
133. Good. Good. Okay. So I took the original formula. I replaced f of X with 100, but I'm not changing the X because that's what I'm solving for. X represents the year since 1990. So I need to know what that is since it's asking for what year. Okay? It's going to be a little bit of a longer process. Okay? Which is why there's a lot of space here.
minus 100.
Mm-hmm.
Yes. What formula do you use now?
The one they gave us. So I took this formula that they gave us, and it said, in what years are there going to be 100 filings? And since f of X represents number of filings, we replaced it with 100. We're solving for X because X represents the years. Okay, so we're going to leave X alone, and now we need to solve it. So subtract 100, and so now we got this. If I've got decimals, what's going to be the most logical one to use to solve? Method to solve. Do I want to try and factor that? No. Do you want to try and complete the square? No. What are we going to use? Quadratic formula. Okay. Negative b plus or minus the square root of b squared. B squared minus 4 times a times c over 2a. There's a lot of places where you can go wrong if you're not careful. If you're trying to type that all in at once, you will most likely make a mistake. Okay? So take it piece by piece. Square b first. What is 286 squared? It's 28.6 squared. 28.6 squared. 5.3. 817.96. Okay? 4 times 3.37 times 33. Should be like, what, 5 something?
Last one was 4.34.
440. And 2 times 3.37. What part should I simplify next? Inside the square root. So 817.96 minus 444.84. Say it again. 3.
73.12.
Okay. Okay, now, it gets pretty easy at this part. Alright, so we don't have to worry too much, but you need to solve for both of these. So you need to do the plus and you need to do the minus. So you need to do your 286, or 28.6, plus the square root of 373.12 over 6.74, round to the nearest 10, and do the same thing, but minus. And then we'll talk about those answers, and then we'll be done. So when we add,
11.
subtract.
1.38.
Is that like a perfect square root?
No. That's why I said round.
I know, I'm just.
Plug it in your calculator. The square root of 737.12 and add it to 286 and subtract it from 28.6. Okay. So given the answers 7.1 and 1.4, what years did we have 100 bankruptcy filings? So in the year 1.4?
In the year.
1991.
Remember, what does X represent? What does X represent? Years
1990.
since 1990.
1998.
So, 1 year after 1990. 1991.
So that's 1.4.
Okay, but
What about it? So,
1987.
1997. 7 years after 1990. So in both of those years, there were 100 bankruptcy filings. Okay, so remember what X represents, and then how do we apply it? It's not in the year 1, it's in the year 1991. The year 1997. Alright? Any other last minute questions, comments, concerns, queries, or no? Okay. Your math lab is short.